Now we're going to dive into parts of the atom. There's three main parts to the atom: the electron, the neutron, and the proton, which are both located in the nucleus of the atom. Note the charge on the proton is positive, the charge on the neutron is neutral, and the charge on the electron is negative. So just to make sure you got that, please notice, I needed a pen. I got my pen. Okay, where did it go? There we are. The charge on the electron is negative, and I'll often write electron like that. The charge on the proton then is, well, there's the circle. Proton is positive, and I'll write it like this. The neutron has no charge. It's neutral, and that's the shorthand for the neutron. Now notice the nucleus does not have a membrane around it like a cell. Nucleus just means in the center. Now check this out. If the proton was the size of a bowling ball, what would the size of the electron be? It'd be like the size of the penny. The proton, again, and the neutron. Proton's positive, neutron no charge, and the electron is negative. If a neutron was caught robbing a bank, would it be charged? No, because neutrons are neutral. Why did the proton hate the electron? Because it was so negative. Finding the number of protons is easy. The number of protons, if you look at your periodic table, locate sodium. Yeah, you're probably going to need a periodic table from like now and forever. But the proton number will always be the lesser valued number in the box. Take a look at potassium. How many protons does it have? That's right, 19. Again, it is the one that is in lesser value than the other. Take a look at this. This guy has 16 protons. Look at your periodic table. Who has 16 protons? It's sulfur. And sulfur also has 16 electrons. If I add up 16 positives and 16 negatives, what do you get? 0. That's always true for a neutral atom. So 16 protons and 16 electrons add up to a charge of 0. All atoms are neutral. I'm going to write that down. That one's really important. All atoms are neutral. So the number of protons, if I count all these up, the number of protons will always equal the number of electrons. The number of protons will always equal the number of electrons for a neutral atom. So finding the number of electrons is just as easy as finding the number of protons. So to find the number of electrons, again, it's the same as the protons. So sodium has 11 electrons. And then potassium would have 19 electrons. Now if you remember, there's three parts to the atom: the protons, the neutrons, and the electrons. So now we're going to learn to find the number of neutrons, and it's really very easy. Know this formula and you're good to go. So the atomic mass is equal to the protons plus the neutrons. The electrons have so little mass, we don't care. Here we go. So the atomic mass of iron is 56. The number of protons of iron, 26. So if you substitute those values into that equation, the number of neutrons is then 30. All right, what is the atomic mass of boron? Oh, wait, there's a stupid decimal there. Yeah, we should probably get rid of that. We don't want to deal with stupid decimals. So you want to round that to the nearest ones place. I'm going to write that down. Round the mass. Round the mass. Remember, if I write it down, you should too. Round the mass to the nearest ones place. Okay, so the atomic mass is 10.811. Round that to the nearest ones place, you get 11. How many protons does boron have? 5. So how many neutrons will this guy have? Well, the formula says, remember, mass is equal to protons plus the neutrons. And the mass here is 11. The number of protons is 5. Whoops, that should be a plus sign. Plus neutrons. So how many neutrons? 6. Yay, we're done. Let's try another one. Atomic mass of aluminum, rounded to the nearest ones place, is 27. How many protons? 13. How many neutrons? 14 is correct. By now you should be asking, well, what's up with those decimals anyway? Why are they there? Well, it has to do with this word isotopes. Dalton said, if you remember, that all atoms of a given element are identical, and he was wrong. You know that there were parts to the atom. Well, the thing is with isotopes is it's the same atom, but the atoms have, so that means they have the same number of protons, but those atoms happen to have different numbers of neutrons. I've had people ask me, well, why do they have different numbers of neutrons? I'm like, I don't know, that's just the way they exist in nature. So isotopes, same atom, but different numbers of neutrons. So if we look at all of the carbons in the whole universe, we find that most of them do weigh 12, but a few weigh 13, and a few more weigh 14. And if I actually do the math, I find out that 99% of them do weigh 12, very small percentage weigh 13 and 14, and if I add all that up and do the math, I discover that that equals 12.011. That's why they're decimals. Not every single carbon in the universe has the same number of neutrons. And I'm going to redo this slide. When you look at the periodic table of elements, what you're really seeing is the weighted average of all of the isotopes for that given element. All of them. So an isotope exactly? Well, let's take a look at hydrogen. These guys all have the same number of protons. Take a look. 3 isotopes of hydrogen have, oh, there's my pen, 1 proton there, 1 proton there, and 1 proton there. But these guys have different numbers of neutrons. This is the format we use to reflect the particular isotope we're talking about. A in this case reflects the atomic mass, X is the symbol, and Z equals the number of protons. Taking a look again at these 3 isotopes of hydrogen, we're just going to focus on this first one. So what would X be? Well, X is hydrogen, it's just H. A is the atomic mass. Well, that's 1. Hydrogen weighs 1 because it has 1 proton. And Z then equals 1. Number of protons is 1. Let's look at the second isotope of hydrogen. X again is H. A is the atomic mass. Remember, the mass equals protons plus neutrons. So this isotope, whoops, bad circle, this isotope has a mass of 2. 1 proton plus 1 neutron equals 2. And the atomic number for this guy, the number of protons, well, that doesn't change for hydrogen. It's always 1. Take a minute and see if you can jot the symbol for this third isotope of hydrogen. If you came up with that, you're right. All right, up next, the periodic table.